T period alpha IT sigma square root of T. You see that? So given this single period information is given, assuming market is weakly efficient at least, then we are able to find T period alpha, T period sigma. Okay? And then just treat this one as the one that we play. Right? The rest of them are exactly identical. And then we can ignore this. And we just play with this covariant correlation coefficient and the alpha T and sigma T. And then we find the corresponding mu using this T period. And then we are also calculating omega for T period using what information? This information, not this, right? Everybody follow me? No problem, right? How easy that is going to be. Makes sense, correct? All right, so let's try that. Let's try with the sigma square root of T. That is equal to what? This sigma, right? Correct? Times square root of, we have to have a time. Here, setup is already, not only we have a risk preference parameter, gamma, we have also time period. In this case, 3, I want to change that to 1. Okay? Let's change, sorry. Let me change this to 1. Let's see what happens. Then here, sigma times square root of time 1, and then I need to anchor this, correct? Because I want to copy this to the right side. So F40, you got this name? Which one is it? Square root of
E7.
Okay. Of course, it's supposed to be the same, right? Because we assume T is equal to 1. Okay, then I can simply copy it. So we are going to ignore this, we play with this. Okay, let's say the alpha T is the same as this alpha times B7, and then I anchor that. One. Like this, right? Gotta be same, correct? If you change that into 2, let's see what happens. If I change that to, look at this figure. Did you see it is double, right? Correct? It is multiplied by square root of 2, which is equal to 3. But as you see there, if we change the time, our necessary information that we have to have as an relation problem will change. So let me change back to 1. Then the next one is that we have to provide what? Some kind of initial starting value, right?
What about mu?
Oh, we got it, yes. 0.2, 0.2. Yeah. Let's try compute this. Mu is, should I use this alpha or this alpha? Top one? Top 2. So alpha t, that is alpha, plus 0.5 times what? This sigma F27 squared. We got that. So initial starting value is this, and then let me calculate mu p with this weight W, this is equal to m mod. And then we have to have a 1 by 3 W, comma, and then transpose this mu, close parenthesis, close parenthesis, control shift enter, we got the mu p. Here,
No square root.
oh, well,
Next one.
next one is equal to square root, and then m mod. We need to have another m mod, right? M mod. This W, comma, and then omega, which we are supposed to create it right there. Comma, so that we have a W prime omega, and then entire m mod is going to consider to be 1 by 3, and we need to again multiply that by W, which is transpose this one, close parenthesis. So that parenthesis cover up to that one and another one. Did I print everything? Do I need one more? Okay. Okay? Yeah, it's the same thing. I mean, I'm very confident that you know what I'm doing. So even if you could not follow what I'm doing, so let me do Control Shift Enter. Of course, you don't get that value because we have used blank 3 by 3. So let's construct this. First, this is supposed to be stock S&P 5 covariance between S&P 500 and S&P 500. So that is equal to what do we do? Variance standard deviations squared. So we are using this, square it, right? And then this one is supposed to be correlation coefficient times S&P 500 times Treasury bond. You may not do it now because you already mastered it. All you need to do is you are repeating the same thing with this one only, okay? So let me just go speed up. Correlation coefficient times standard deviation times S&P 500 and C bar standard deviation. And then we know that it's supposed to be equal to this. This one is supposed to be square T-bond standard deviation that is equal to correlation coefficient times this standard deviation times this. So now again that is equal to this quantity, free condition, and this one is supposed to be equal to second. And this one has to be equal to C bond deviation square. Okay? You want to do it? By entering the number here, you notice that the C quantity is calculated, right? Okay. So let me go up. this time I need to set up objective function which is equal to mu p minus 0.5 times gamma times, this guy is quite risk averse, so 6 times sigma p square is sigma p square. Okay, so we already finished. We are ready to use solver, and using the solver, whatever the solution we get, I like to put the allocation and copy this. You can see my there. When investment horizon is 1. When investment is 2, all you need to do is simply change this 2 and then click solver, automatically solve it, and then copy that. Okay? Let's try that. I need to go to File, Option, add in, already, go, solver, okay, and then go to data, solver. Let's see, objective function. H9, it's already set, we want to maximize by changing what variable from F13 through H13. Subject to no constraint. First constraint, which is E16 is equal to H16. Right? So it's done. Right? So let's solve it. And solver found the solution. Okay, clicking it, we got this answer. So we copy this, paste, special value only, and then UP is this, copy, and paste. So, I, who has investment horizon is 1, with the gamma is equal to 3, GLBH managers recommend me to allocate my money just like this. Okay, 51%, that's quite large. And the 25% T1, C1, 20%. So that has been recommended. Now let's pick up Mr. Thompson. Mr. Thompson has an investment horizon over 2 years. Hey, in their survey, you remember that with the survey, some questionnaire, we check with each client before actually they open an account. We give a questionnaire. You did that, right? Did you? Find out. Go to solver. Solve it. Solver found the solution. Okay. So I copy this and paste that. Paste special value, and then repeat this. Copy. Paste. Special value. Oops. No change in asset allocation. Of course, UP is also doubled, correct? Okay. And the sigma P is increased by square root of T. Square root of 2. Right? No asset allocation. You try the rest of them, 3, 5, what do you expect? You get the same. So what does that mean? Your professor lied to you?
Yeah.
They did. They are teaching this one, and then they say, hey, you better put more money in risky assets since your retirement is way far to go.